Hello, welcome to the today's session. In today's session, we will discuss about the right circular cone having certain base and the axis side given, and then it is cut by an auxiliary inclined plane in such a way that it is passing through the apex of the cone at certain distance from the apex, and then we will have to draw the front view, sectional top view, true shape of the section, and then we will develop the lateral surface of the truncated cone. So let us proceed. Let us read the question. A right circular cone of base diameter 40 mm, axis height 50 mm has its base on the HP. It is cut by an auxiliary inclined plane, that is AIP, which makes an angle 45 degree to the HP, and as this it is a auxiliary inclined plane, so this plane will be perpendicular to the VP and maintaining an angle 45 degree with the HP. It passes through the point on the axis 20 mm below from the apex, and we have to draw the front view, sectional top view, true shape of the section, and then we are going to develop the surface of the truncated zone. So let's proceed. So we see that the right circular cone base will be a circle. So in this case, the radius of the circle will be 20 mm. So let us take the center point and let us take the radius as 20. Now we divide this circle into the 8 equal parts. We say that the quadrant of the circle should be on, so that we can locate its end point, and let us connect it with the center of a circle. Now we wanted to divide this circle into the 8 equal parts. For that we will use the array command, polar array we will use. So let us select the line which is connecting the center and the quadrant, enter, select the center point of the array. We see that by default the circle is divided into the 6 equal parts. Now we want the items to be 8, so that it divided into the 8 equal parts. Now let us give it the names to this each endpoint which is divided into. So let us create one to 8 using this multi-text option. Like this, we will go on adding a new line and the new name, and then we will select it together and we will explode it like this, so that we can appropriately place the each point at the required location. For that we switch off the ortho mode. Let us take this 2, let us transfer this 3, transfer 4, transfer 5, transfer 6, yeah, we need to choose it very carefully, otherwise the OSNAP will fetch it towards the nearest point series, right? So we need to take it, and in this case you might have to switch off the OSNAP if required. 6, 7, then let us keep it a for 8. Okay, now transfer the points on the XY line. So for that let us transfer this like this, and we should make sure that the ortho mode is on. So I am redrawing the line. So from 1 to the XY line, then from the 5 to the XY line. Now I wanted to take the axis. So first what I will do, I will select all the line, I will make it as continuous, I will select the line thickness as 0.09. So I will keep the default as continuous, and the default as 0.09. Now I want the axis line, so I will load the center line, load center line. I will also require the dotted line if at all, maybe in a later case. So let us load it now. Okay. In this case, the global factor is 1. We may require to be changed later on. So now let us take the center line. So this is the intersection of the 3 and 7. So from this, let us select the height of the cone, which is nothing but a 50 in this case. Okay. So we see that this line is center line, but it doesn't seems to be. So let us use the LT scale command to change the scale. Now let us select it as 0.25. We say that the now line type is appropriately looked as a center line. Now select the continuous line again with the same thickness of 0.09 and connect the apex with these endpoints. So these are our end generators. This with the this. Okay. So now let us transfer this 2 and 8 projection here, and let us also connect it to the apex. Similarly, the projections obtained from the 4 and 6, we will also transfer it from this base point to the apex. Now let us give it the names to these base points. So for that, again we create a multi-line text. So in this case, 1 dash, increasing the height 5, okay, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash, 8 dash. Let us explode. Now we will place it. So this base is switch off the ortho mode. This is our 1 dash, then 2 dash and 8 dash on the same horizontal line. So this is the 2 dash. Okay, so in this case the 2 dash is automatically faced towards the nearest snap point. So we will switch off the snap point and let us zoom it so that we can appropriately place it. Okay, so this 2 dash comma 8 dash. So this point is 2 and this point is 8. Okay, so now 3 dash comma 7 dash, 3 dash. So let us move this 3 dash. This is 3 dash comma 7 dash. So this is 4 dash comma 6 dash. The last point is nothing but the end generator, which is a 5 dash. Now let us show the sorry center distance of 20 mm from the top. Let us switch on the O snap mode. So this is 20 mm. Switch on this. Let us click it like this. Okay. Let us give the name to this apex also. So copy, switch off the ortho, and let us give it the name as, let us call it as O dash. Okay. Let us show this distance. So distance is 20. Now let us go back to our previous stage. Let us check the dimensions. Okay, you might have to change the annotation style to ISO 25. So manage this dimension style, modify, We require the text height to be, let us say, 3, and then text alignment is ISO standard. Okay, we may change it the offset from the dimension line to 1. Click on OK and set current. You might have to modify the primary units in this. Instead of comma, we will keep it as period, so that the decimal point will be shown by a dot instead of a comma. Now set current and click on OK. You see that the leader line appears. Now let us trace this center line like this. Let us zoom in so that we can appropriately select it. Okay. Yeah, this is the center line. So we see that this is a center line outside of the dimension line. So let us select it like this. Check it out whether it is a center line or yeah. Okay, it is getting overlapped. So let us move this little bit inside, and then we will select this line type as center line. Yes, it is a center line. Okay, so it is getting overlapped, that's why we were not able to see. So retaking the dimensions again. So this, okay, like this. Now we want it to be inclined at an angle 45 degrees. So let us click it on this rotate, and then we'll keep this base point. And what is the angle we require? 45 degree. So we see that it is now inclined, right? Now the dimension point is changed. So we will take these dimensions from the apex to the point on the axis. We see that still the distance is 20. Okay. So now this, which is retaining part, we will show it by using the dark lines. So let us redraw it. Okay, so this is nothing but the retained part. So let us make it thick. Switch on the line weights. See that the base is also needs to be thickened. So let us take the mesh properties, base. Okay, then let us clip it on the zoom again, and this is nothing but the outer part which needs to be again made it as a thick. Okay, now let us transfer the annotations from this generators to the bottom. For before that, we give the names to this intersections of the section lines with the different generators. So let us, for that we will create another multi-line text. Let us give it the name as A dash. A dash. So we see that this is cutting at the only one end. So A dash, B dash, C dash, D dash, E dash, F dash, G dash, and H dash. So in this way we will go in a sequence. So this will be A dash, this will be B dash, C dash, D dash, E dash, F dash, G dash, and H dash. In this way we will go. So B dash, A dash, B dash, C dash, D dash, E dash, F dash, G dash, and H dash. So we select it and we will explode it. So now A dash is nothing but on this A generator. So let us move it. So this is our point A dash. Then this point is B dash and H dash. So this is B dash. So let us switch off this O snap. So this point is B dash comma S dash. B dash comma S dash. This point is C dash and G dash. This point is D dash comma F dash. Let us move it little bit further, or just for convenience, or we can reduce it the size to rather than 5 mm as 3. So let us take it properties, make it height as 3, okay, and then let us keep it the match properties with select it, match properties and select all B, H, C, G, E, D, F. Okay, so now we will move this D and F. This is point F, and let us take this point is D. Now transfer these annotations A dash in the top view. For that, again we will see, and let us zoom it only to this inside part. Only this much part let us say zoom for the convenience. So this A dash is on the generator of 1. So let us transfer it vertically. So now let us use the points here, otherwise the number of projections will get very much large. So let us take it. O snap is on. So this is point A. Okay. So now let us take the P type. So let us take this. Set size in absolute unit, and the point size let us take it as 3. Let us take the generator obtained from the intersection of the 2 8 with the BH. So let us take this point as 2 and this point as H. So let us create the multi-line text here. A, let us keep the height as 3. So B, C, D, E, F, G, H, and again we will explode it. Okay, now let us transfer this A. So this point is A. So now again O snap needs to be switched off for appropriate placement. So this is A. Sorry. This is B. This point is H. Let us transfer this C and G. For the transferring the C and G, we need to as these points on vertical line. So if we transfer it directly, we won't get the single point. So we transfer it along the adjacent generator, which is nothing but a generator in this case, either 1 or 5. So let us transfer it on the 5. So this is now obtained vertically like this. Let us switch on the ortho mode. So this is nothing but the C and G transferred on the generator of 5, and then it is transferred again on the generator of 5, and then we will transfer it back to the axis of the C and G. So that is on this vertical axis. So for that we will use a arc. So we in this case know the start, center and end. So select the center point of the arc. So we select this center point of the arc, then we select the start point, and then this is our end point. Similarly, let us mirror it along this. So in this ways, sorry, I deleted the source. So mirror, this needs to be mirror. This is the line, this, and I do not want the source to be erased. So erase the source, no. Okay. So little extra line is created. So in this case, I want the C and G. So C and G is brought on this vertical axis now. So let us transfer this C. So this point is C. Switch off the snap and ortho mode. So this point is C and this point will be G. Now we need to track the D and F. So for getting the D and F, again take this ortho mode and the snap mode on. So this D and F, so this point is D and this point is F. Okay. So now let us take the last point, that is nothing but E, which is on the edge of phi. So this point is, let us take it again. Which is nothing but the line obtained from here. So this point is E. So let us transfer this E, and then this D, this point is D, and let us transfer this point F here. Now as this inclined plane is this auxiliary inclined plane is inclined, so although we are getting the ellipse, but this ellipse is not a regular ellipse, so we cannot join it by using the conventional method. So we will have to use a spline in this case. So let us use the spline. So let us start with the point A, snap on, B, C, D, then this E, then this F, then this G, H, A, and let us go back to the C and then little bit inside. Then we enter. Let us zoom this portion. Yeah, you see that this is somewhat irregular part that is created. So this is the ellipse we wanted, right? So trim out the portion which is not required. So this is the extra portion. So this is our retain part. So that we will make it as thick like this. Okay, and then we will give the hatching to this portion. Now let us select the pattern of ANSI 31. Now see that inside this we say that too many lines are there, so we might have to delete this so that hatching appears to be correct, or otherwise we will have to hatch it for the 6 different durations, 6 different portions or 8 different portions, and then it will become complicated. So we can delete this. So let us hatch it. pattern is this, select that. Okay, and see 31. Okay, then you might want to show the center line, so we can draw it. So this is the center line we draw. That is nothing but only the 4 different lines we are showing here. Now in this case we wanted to draw the true shape of the section. So for that we will create the points here, 1, 2, 3, 4. In this way the points are created. Now select this line, select this annotations, then we copy this, switch on the ortho mode. I think E is remaining, so let us zoom it first before copying. So select this, we select the A dash, B dash, S dash, C dash, G dash, yeah. Also need to select these points so that we will get the precise location. Then we copy and then we move it. Now let us zoom it. So we may have to zoom it or move it little bit ahead. So move, yes, okay, move along with its annotations. So this is move ahead. Now we need to rotate it by -45. That is, we may have to make it at horizontal. So rotate. Let us select the base point and then let us select the -45 so that it becomes horizontal. Now again let us zoom it. So again we take the points. So this is our A point, which is nothing but obtained from this A. So this is A. Let us take this B point. So this point is B. Let us take the H point. So this is H. Let us take the G point. G point. Let us take the C point. Let us take this. For the F, as I have deleted the intersections, I need to show it again here. So for that, I might have to redraw this polar array command. So I am selecting this, then I am selecting the center point and then making it as 8 parts. This way, this I am getting the intersection of this F. So this is how my F. F. This is D. Then finally, I want the point E. This point is E. Now let us join it by using the spline again. 1, 2, 3, 4, 5, 6, 7, 8. Go back to again this, and then at least 2 point we can take ahead, then enter. Now I am transferring the annotations. A, so this is our A. Switch off the OSNAP and ortho mode. A, B, copy, B, copy C, C, then copying D, copying E, copying F. Otherwise, we can also create this multi-line text again, and then we transfer these points. Then we transfer G, and then last point is transferred is H. Copy H. Now we zoom it, this portion, Z, we do in the window, and let us trim out the extra portion. Okay. Probably we need to redraw in this case if it is not getting trimmed properly. Okay, we see that it is not getting trimmed properly. So we redraw it. So snap mode on. 2, 3, 4, 5, 7, 8, and okay. So trim this portion. Let us draw this some crossing line and then trim it. Hope so it will work. Okay, let us extend. Yes, we see that it is getting trimmed now. Okay, so this much portion which was getting trimmed. Now let us draw one more intersecting line so that it gets trimmed properly. So let us strike this. Let us try to trim it. It is not getting trimmed. So let us move it. Now let us try to trim it. Okay. So in this, let us take this help of this vertices that is displayed. Let us move these vertices on this point. And now let us try to trim this. Yeah. Okay. So it might take considerable efforts for making it look like a ellipse. So now let us make it thicker. Okay. Now let us take this hatch ANSI 31. Yeah. Now let us go back to this zoom enter E enter. So in this case we have created the front view, sectional top view and the true shape of the section. Now we wanted to create the development of the lateral cones. For that we draw a line parallel to this. So let us zoom it. So let us draw one line, copy, switch on the ortho mode like this. Now we will use the formula. Let us write down the formula. Formula is theta is equals to small r divided by capital R into 360. So what is the small r in this case? Small r is the nothing but the radius of the cone. Capital R is in this case is nothing but the length of the slant height of the cone into 360. That will give us the angle included by this cone. So let us find out what is the theta we get in this case and what is the slant height. So let us annotate this. So in this case we know that the radius in this case is 20. Let us find out what is the length of this slant height. In this case it is 53.85. So that will give us 20 divided by 53.85 into 360, and in this case we get the value around at 133. And if we do the calculation precisely, so we get it this as 133.70 degree. So 133.70. So we will approximate it to the 133. So let us take it as 133 degree. Okay. So included angle in this case we will take it as 133. So now let us again zoom back, and in this case let us take this line as thin 0.09. Okay. Deleted that line. Now we take an arc. So in this case we know the angle and we know the start point. So let us take the this as center. This is our start point, and we take the angle in this case as 133 degree. Oh wait, we need to switch off the ortho mode. So center start angle, center, this is our starting point, and then angle we want it as 133 degree, and now we join this. Now we wanted to divide this into the 9 equal parts, because once we open this we will see that it is made up of this cone. So this cone is made up of this open sector of a circle. So for that we will use a path array. So in this case select the object, then we select the path curve, and then in this case instead of measure we will select it at divide. In this case the angle that we want in this case is 9 degree, we items with that we need is 9. So that's how this is divided into the 9 equal parts. Now let us give it the numbers. So we give the numbers as 1 2, let us say 8 and 1 again. So for that we can either create this again multi-line text here, 1, let us take it as 5, 1 2 3 4 5 6 7 8 and 1, and then we explode it. So now we have done it. Now transfer this. So this is a 1 2, switch off the ortho mode, 2 3 4 5 6 7 8, and then now we transfer this 1. So in this way we have shown this. Okay. Now let us zoom little bit so that we can transfer these intersections on this. So this is nothing but intersection obtained from the generator of 1. So ortho mode is on. So let us take this, switch on the O snap. So this is our point 1. Okay. So let us copy this. Let us copy this A dash, copy. So this point is our A dash. Now let us transfer the projection from the B and H, which is nothing but obtained on the generator of 2 and 8. So let us transfer this on the generator of 1 first, then we rotate it. So now let us rotate it by using the center start center radius. So we know in this case the center point, and we know the radius in this case. So let us take this, let us take the center. So this is our center and this is our radius. In this case we have done. So this is nothing but the intersection obtained from the B and H. So we obtain it on the edge of 1, then we transfer. So the point B dash is, copy, it is nothing but obtained on the, this point is B dash, and let us move it little bit 0. So let us use this option. So now we move this H, copy, so ortho off, this point is S dash. Now we transfer the C and G. So this point is for C and G. Let us transfer the D and F. This is for D and F. Let us transfer the E, and then we will transfer those points respectively on their respective edges. So let us take this R command, start and radius, take it the center point in this case. So this is our reference point, and let us click it on this. So this is we have created for C and G. So let us transfer the C, copy, says on the intersection of 3 and 7. So let us do it. So this point is C, and let us transfer the point G, which is nothing but obtained on the intersection of the generator 7. So this point is nothing but G. Okay. So now let us transfer the D and F. For that, again we take the arc command, select the center. So this center is selected, O snap on. Okay. So this D and F is nothing but obtained on the generator of 4 and 6. So D is on the 4. So this point is D, and F point is on the, let us zoom it, F, copy, let us copy this F, so let us zoom it little bit. So this F is transferred from here on the generator of 4 and 6. So this is C and F. Let us check it out whether it is correct or not. So yes, so this is the point F, and this 4 is nothing but this D is nothing but on the 4. So let us use the points so that we get it appropriately. So this is nothing but the point B. This is point C on the 3. This is point D on 4. Then the point F is on 6. Point G is on 7. This is point 7. G is on 7. Okay. So we now locate the E. Again we take the center arc end. So center, we take this radius, we draw it, and we locate it on the edge of phi. So the point phi is nothing but this point. So let us transfer the point E dash, copy, switch off those O snap. This way it is transferred. Now we join in a sequence. So again here we will have to use the spline. So this is point our A. So before that we let us zoom it and pan it. So let us pan first. If required we will zoom. Okay, so Z, then let us take it E, and let us Z only on this window. Okay, so now we join in a sequence using the spline. So switch on the O snap. This point is A, B, C, D, E, F, yeah, one more point I need to locate. This A point also need to be located on the edge of this first, right? So from here I need to locate this center point, this. So this point is also A, which is also on the edge of A. So this is A again, right? So I have this H on the 8, this point. So this is nothing but B and H, and this is 8, and the G is nothing but on the generator of 3 and 7. So which is obtained from the so this B is on the 2 and on the H. Let us check it. Yes, B and H are on the same line. Let us check the C and G. So this is C on the 3 and on the same portion we get the H. Yeah, let us check the D and F. D is on this line, so this D is on 4. Yes, this F needs to be moved. So let us move this F from here to here. So this is F. Okay. So now let us join. So this A, B, C, D, E, F, G, H, A, and this. Now we trim it and let us trim this portion also, which is not required, and then we join this. This we make it at thicker. Then we join this edge. Similarly, we make this edge. We want to make this edge also thicker. We want to say this also, which is nothing but the retained parts, we will make this thicker. So that completes our development. So now give it the names. So we have this as sectional top view, sectional top view. Let us increase the annotation size to 5. Copy. This is our front view. Front view. Let us place it in the center. I think I have moved this original also. So rewrite down its sectional top view. So now this is copy. This is our true shape of the section. True shape of true shape of section and this is our development of surface. Copy. DEVE. Development of surfaces of lateral cone. And in this case we can show the what is the angle that we have obtained. This case, so this is okay, and even if you don't show that, still okay. Okay, good day.